the Black Rock Desert. A barren wilderness in Nevada. The setting for one of the most awesome challenges known to mankind. The land speed record. Engineering at its most extreme. Which in 1997 took the British thrust SSC to a mind-blowing 763 miles per hour. A record that has remained untouched for over 2 decades. But now in Perth, Australia, an ambitious team are building a car that they believe will one day rewrite history. The Aussie Invader.
Well, here she is, soon to be the world's fastest car, Aussie Invader 5R. 55 feet in length, 6.5 tonne in weight. Very, very powerful, 200,000 horsepower, 62,000 pound of thrust.
This extraordinary machine is the culmination of a life's work for inventor and driver Rosco McGlashan.
I believe this car is the most innovative land speed car ever conceived. This baby here is a solution to go very, very fast. This car, it's perfect. It's got everything in the right place. It's a revelation.
To create a car as fast as a speeding bullet requires NASA-like technology. Keith and Jenny Lovett are part of the team striving to create this engineering first.
This is absolutely one of the most exciting high-speed car projects in the world.
The dynamics of the car do share with the aerospace, the rocket engine, the wheel speeds. Even the paint finish on the car has to be able to cope with super high speeds.
Aussie Invader's futuristic bodywork has just been completed. The team is now working on its propulsion system. But this will not only have to break the land speed record. Incredibly, Rosco has another audacious goal in his sights.
The next big thing that we want to achieve in the land speed record is what we say is the holy grail of auto racing, 1,000 mile an hour. To achieve 1,000 mile an hour in a car or 1.4 Mach is impossible. And that's why we're doing it. We love it.
This is a one-off, absolute unique car. Aussie Invader 5R is the ultimate of cars.
Aussie Invader is constructed around a unique steel tube. 2 huge fuel tanks feed a liquid propellant rocket engine. Powerful enough to break the sound barrier in 15 seconds. Before state-of-the-art air brakes and a parachute system bring this horizontal rocket to a halt at the end of its 24-kilometre run.
That's good. Yep.
12-volt.
But as this pioneering team look to enter the unknown, the challenges are immense. How is it possible to create fighter jet performance on 4 wheels?
To make a car go as fast as we want to go, which is 1.4 Mach, you need a heap of power.
How do you ensure Aussie Invader won't break up?
It has to be made to withstand some extreme forces. 1,000 miles an hour with wheels turning at 10,000 RPM, strange things happen.
And how can it safely slow down from supersonic speeds?
It has been a challenge to develop a braking system for the car because there is no book that tells us what we need to do.
The fact that few have even attempted to travel this fast on land poses perhaps the biggest problem.
I think that 3 times as many people have gone to the moon that have gone 600 mile an hour in a car. So it's a pretty amazing thing to achieve.
So how do you even know what shape to build?
A lot of people say to me, how do you make a car go 1,000 mile an hour? What's the difference between a 1,000 mile an hour car and my road car? Obviously the aerodynamics, making the car stay on the ground. It's just got to have the right load on the ground at all times. The aerodynamics are possibly the major thing to get right.
Can the pioneers of the past shed any light on what it takes to construct the fastest car on the planet? The land speed record was initially the reserve of the French aristocracy. In 1898, Count Gaston de Chazelou-Lobar set the first record, reaching 39 miles an hour in a production car. But Belgian car manufacturer Camille Janatzi soon stole his crown, propelling his car to 41 miles an hour. In an ego-fueled rivalry of one-upmanship, the Count finally broke the 50 miles an hour barrier, and it seemed the battle was won. But Janatzi was determined not to be beaten. Like Aussie Invader's team, he had to come up with something completely different. Andrew Steele has come to the Cité de l'Automobile in Mulhouse, France, to get up to speed with Janatzi's inspired solution. A totally new breed of car.
This is a full-size replica of that incredible vehicle. It's called La Jamais Content, which means the never satisfied. And it was a revolution in automotive engineering.
This was the first ever car specifically designed to break the land speed record. Few people have had the chance to drive it, but today, the museum are making an exception.
Wow, bit tight in here. This is like a 25-point turn.
Its aerodynamic body is made from a lightweight material called partinium.
Right, let's take this thing for a spin.
Never before used in car manufacturing.
Here we go.
In April 1899, Janatzi used the car to set a new land speed record of just under 66 miles an hour.
It's not doing 0 to 60 very fast.
Making him the first person ever to drive a car over 100 kilometers per hour.
Just coming out of the corner, and I'm going to stick pedal to the metal now. This just isn't like any car I've ever driven before. I mean, you can hear it sounds like, what, a dinosaur? It hasn't got a steering wheel, it's got this incredible sort of tiller system. It's also the days before the internal combustion engine became popular. And that means that it's driven by two 25 kilowatt electric motors, giving me a whopping 68 horsepower under my right foot.
Built purely for straight-line speed, the Jamais Content's bullet-like design broke the mold of automobile aerodynamics. The kind of forward-thinking that Aussie Invader will have to adopt.
Just leaning into the corner now, I feel so unsteady going around this not even particularly tight turn. This is absolutely terrifying. It's incredible to think this was once the fastest car in the world.
Janatzi's record would stand for almost 3 years, proving that by specially engineering a car, it was possible to go faster than ever before.
What a machine.
In Perth, a team of engineers are constructing a one-of-a-kind car that they hope could reach an earth-shattering 1,000 miles an hour. Like Camille Janatzi, inventor and driver Rosco McGlashan's life is focused on one thing.
The land speed record has been something that I've wanted to achieve all my life. Quit school at 12 years of age to set the record, and here I am many, many years later still chasing that elusive goal.
Roscoe's quest for speed began with homemade go-karts. As an adult, he upped the ante.
Race things like rocket-powered motorcycles, jet dragsters, a lot of stuff.
In the 1990s, Rosco would earn himself legendary status as he targeted the Australian land speed record.
Initially, what we wanted to do is I want to claim the title of fastest Aussie on Earth, and it took us some time to do that.
Yeah, how you doing, mate? Good, mate. That looked really spectacular, looked really beautiful. Yeah, good, mate.
It wasn't until '94 that we actually set the record at 500 mile an hour.
The average speed for the 2 runs was 801.3 kilometres per hour.
We can bring the champagne. So we've got it, guys, we've got it.
One of our earlier passes, we ran 638 mile an hour on a one-way pass. So that was actually faster than the world record at the time.
But an official land speed record requires 2 timed runs. Unfortunately for Rosco, a freak storm made this impossible.
Within an hour, exactly an hour, we got to be coming back the opposite direction. We couldn't back it up, and but we went pretty good. We did pretty good.
Now, 2 decades later, he believes his new groundbreaking design has the potential to become the fastest car on the planet. As with Genazzi's bullet-like innovation, the starting point for Rosco is creating the right shape.
We thought if you wanted to go to the moon, you start off with a cylindrical object, have a point at the top of it, rocket motor in the bum, pressure vessels all the way through, and you sit under the point at the top. Well, obviously, in a car, we want to be sitting on the centre of gravity. So the centre of gravity is about here, and we're sitting right behind it, so we know what the car's doing. So obviously, if the front of the car's moving, if the back's moving, we want to know about it.
Aussie Invader's nose is angled down to avoid lift. To house the rocket's huge fuel tanks, a unique 12-metre-long steel tube forms the car's colossal front cylinder.
What we call the mainframe is a pipe, if you like. It's been dimpled to get the right boundary layer airflow over it. And if you measure this car from the front axle to the back axle, there's possibly 2 mil difference. So it's stiff, it's strong. Yeah, I think it's a perfect solution.
To reach 1,000 miles an hour, Aussie Invader's cylindrical body would have to cope with some extreme forces. Approaching the sound barrier, or supersonic travel, would disrupt the airflow, causing a potentially devastating problem underneath the car.
Just before it's approaching supersonic, there's a shockwave that forms on the car. The problem with the car is it cannot dissipate that shockwave downwards because it hits the ground. And if you've got a flat belly underneath the car, it goes bang, 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 all the way down.
These trapped shockwaves could throw Aussie Invader dangerously off course. So the team came up with an ingenious solution.
We made a V underbelly on the car. The further back it goes, the sharper it gets. So as that shockwave moves backwards, the shockwave can dissipate off the side of the car and go outwards instead of hitting the ground and bouncing back on the car.
But if this engineering marvel is to ever travel nearly 250 miles an hour faster than any car before it, the team will need to overcome another seemingly impossible problem.
We believe we need 62,000 pounds of thrust to get us where we want to go.
So how do you create more power than any land-based vehicle has ever produced?
3, 2, 1.
The steering wheel still removes, full steering wheel off to climb in and access the car in through here.
In Perth, Australia, a trailblazing team are developing one of the world's most ambitious engineering projects. Aussie Invader, a supercar they believe will one day achieve the impossible. To drive at 1,000 miles an hour.
Aussie Invader 5 is the pinnacle of all land speed cars. I just don't think there will be another car built with this capable power that this one has got.
Aussie Invader is aiming to travel 5 times faster than a crossbow bolt, 4 times quicker than an Indy 500 racing car, and double the cruising speed of an Airbus A330. But to achieve this, it will have to generate more thrust than any other car, creating a massive problem for inventor and driver Rosco McGlashan.
I'm in the speed business, so we want to go really, really fast. We believe we need 62,000 pounds of thrust to get us where we want to go, to the 1,000 mile an hour. And there's not many ways to get that.
Land speed records have been set with a wide range of power sources. In the 60s, the American Goldenrod was fitted with 4 combustion engines. But its piston-powered record was 600 miles an hour short of Aussie Invader's 1,000 mile an hour target. Engineering greats like Spirit of America were fitted with turbojets. But these are not the ideal solution for Rosco.
The things that scare us with jets is where the engines will suck in like a big vacuum cleaner, a stone or a rock or a wrench into the engine, kill the engine, you lose the record. So we're done with jets.
So what could propel Aussie Invader to its impossible dream? Can the pioneers of the past help out? In Dudenhofen, Bavaria, a test track is playing host to an engineering masterpiece that could help Aussie Invader. Behind the wheel is vintage car specialist Uwe Mertin.
This car was originally driven in 1928, and to drive it here now, 90 years later, it's just amazing to have this chance to be here and to drive this car.
This is a replica of the legendary Opel Rack 2. Its extraordinary wings give a clue that this was no ordinary car.
The original car had a kind of a different, you can't really say engine, it was just powered in a different way.
With the sole goal of out-and-out speed, the carmaker's director of testing, Fritz von Opel, replaced the combustion engine with something quite incredible.
What you see here are 24 rockets. And imagine there was no engine inside, no transmission, just the rockets. And the driver had the steering wheel, that was it. And then bringing up this car to a speed of 238 kilometers per hour, it's just amazing.
Von Opel used solid fuel rockets. Once lit, their powered propellant burnt outwards, releasing high-speed gases, propelling the car with 6 tons of thrust.
Whenever they were ignited, it was like a firework. The driver ignited with a pedal, always 4 rockets at a time. So 24 rockets, he had to do it 6 times, and then the car went faster and faster and faster up to the end speed.
To appreciate the rocket's phenomenal performance, Uwe has a scaled-down demonstration.
I'm going to do a fun little challenge with a remote-controlled car. I'm driving up the straight here, maybe 4 seconds to get there. So maybe could we take some inspiration of Fritz from Opel, so to make it faster? So in my hands I have 3 solid fuel rockets. Put the rockets on here. Let me see.
And when 3 fuses are slotted into place, today's pocket rocket is ready for launch.
So I'm gonna light the fuse now. Oh! My God! Similar to what Fritz did with the rocket car.
In 1928, at a Berlin racing circuit, these awesome rockets would launch the Rack 2 into the record books with its 148 mph top speed.
There were tons of smoke. There was a big, like a firewall coming towards you. It was really the first time that people had seen something like this. Fritz von Opel is for sure a pioneer and a German hero.
Aussie Invader is following in the footsteps of the remarkable Rack 2. But its single rocket is being built to drive it almost 7 times faster than its land speed predecessor.
So this is a solution to all our power problems. It's a bipropellant rocket motor and it's designed to produce around 200,000 horsepower. That's more power than the entire grid of a Formula One race.
This bipropellant rocket is engineered around 2 liquids: an oxidizer, white fuming nitric acid, and turpentine, which acts as its fuel. Nitrogen gas stored in 3 giant tanks pressurizes the 2 liquids at 600 psi. When the throttle's opened, the liquids are released into the combustion chamber.
As soon as they see each other, it's instant oomph. There's a massive controlled explosion inside there. They get squeezed through here, which puts a massive amount of pressure through the throat and then out through the nozzle. The same scenario as when you're watering the garden, you put your finger over there, you restrict the flow at the end of the hose, and obviously the pressure goes up massively.
Testing of the rocket's cutting-edge fuel is currently underway at a facility in America's Mojave Desert. When white fuming nitric acid and turpentine are injected together, the result is spectacular.
5, 4, 3, 2, 1.
On land, it's hoped this extraordinary thrust will allow Aussie Invader to cover 440 metres in just 1 second.
When I hit the gas pedal on this car, the 2 mixers go into this into the combustion chamber. The 2 mixers puts out a plume 300 foot out behind it, makes full power in 3 milliseconds, and the temperature inside there gets close to 2,000 degrees Fahrenheit within seconds. That's space technology. Rocket's the only way to go.
Rocket engineering could one day fire Aussie Invader into the land speed history books. But its fuel-guzzling performance creates a major problem.
With the propellant usage on the car's getting 2.5 tonne lighter in 21 seconds.
This could make the Aussie Invader dangerously unstable.
What can actually happen is the car can just lose its directional control and spin like a top either way sideways.
Australian inventor and racing legend Rosco McGlashan is on a mission impossible. To create the world's fastest ever car.
I'm no rocket scientist, but I've got rocket scientists that help me. I've got engineers, I've got welders, I've got fabricators, I've got the best you can possibly get. There's a steering cone that mounts off a rack on the inside here, which gives us 5 degrees. Yeah, just give her a turn for us, Pete, would you mate? So it puts it actually through a 5-degree plane either way, and that's basically all the steering we have.
To date, Aussie Invader has been 15 years in the making. Its designers hope it will one day reach a mind-blowing 1,000 miles an hour in just 20 seconds, making it an engineering first.
There's not a lot of people that can tell you how to do this or work it. There's no land speed book, there's no rocket car building project kit. You have to start from scratch and work forward.
The 9.5-ton Aussie Invader will be rocket-propelled, capable of creating more power than 2 Hornet fighter aircraft. Its engine is 1,300 times more powerful than a family car, engineered to travel 1 mile in an astonishing 4 seconds.
I think the greatest thing about what I'm doing is no one else is doing it. It's too hard. It's the most impossible thing you could attempt to do.
Aussie Invader's projected speeds are staggering. But driving this fast would create an immense problem for a crucial part of the car.
So at 1,000 mile an hour, our wheels have got to turn at 10,000 RPM, so we cannot run tyres, it'll just explode. So one of the biggest obstacles we've had to overcome is having wheels that would turn at that RPM.
The space-age solution is a set of super strong aluminium wheels. Engineer Mal Austin is overseeing their development.
Essentially, it's one of a kind, so you're not going into production with these type of wheels. You've got 900 diameter piece of solid aluminium turning at 10,000 plus RPM. The forces at play are astronomical, hence being the toughest grade of aluminium you could possibly find. Any slight stone or anything it may hit upon the track, it puts an immense lot of force onto the wheel. It's got to be able to withstand a lot of load.
These unique wheels are built to withstand an unbelievable 50,000 G.
Being machined out of one solid piece is the only way to go. It provides with the right tensile strengths. This weighs approximately 140 kilos. Yeah, there's no ring to that, so it's pretty solid.
But if Aussie Invader is ever to achieve a safe supersonic run, it will have to overcome another huge challenge. A problem that nearly killed the pioneering record holder Donald Campbell in the legendary Bluebird.
Donald Campbell, back in about 1960, ran his Bluebird racer and he found that the back of the car came around past the front. So the car couldn't run like an arrow.
It's thought that instability at high speed caused the catastrophic crash. Unwanted lift had nearly cost Campbell his life. Now Rosco McGlashan faces the same danger. To keep Aussie Invader safely on the ground, its centre of gravity must be perfectly positioned. Achieving this with a rocket-powered car is far from easy.
With the propellant usage on the car is getting 2.5 tonne lighter in 21 seconds. What happens, the centre of gravity on the car is moving rearwards, and what can actually happen is the car can just lose its directional control and spin like a top either way sideways.
Can an innovation from the past offer a solution to avoid disaster? Formula One pit engineer Michelle Creighton is used to life in the fast lane. Today, she's at the British Motor Museum, discovering a racing icon that could provide an answer for Aussie Invader.
Wow, this is the beautiful, stunning Jaguar D-Type. This is the car that raced at Le Mans in 1954. It's engineering at its finest. It's so smooth, it's made out of one piece of lightweight aluminium. It's all handcrafted and it's absolutely beautifully finished. Absolutely stunning.
Despite its slick lines. To beat the world's best at the grueling 24-hour Le Mans, the Jaguar team needed all-round super-fast performance. But high-speed sections like the 6-kilometre Mulsanne Straight were posing a problem. When travelling over 170 miles an hour, the D-Type's lightweight body was becoming unstable.
Jaguar knew to compete, their engineers have to come up with something game-changing and iconic to stand a chance.
Aerodynamicist Malcolm Sayer had a simple solution to help the D-Type reach the checkered flag. An invention that could also assist Aussie Invader.
Designed specifically for high speed. Going down the Mulsanne Straight, you're doing 170 miles an hour. Don't want any crosswinds to knock this car. The tail fin is just like a fin on a plane.
This brilliant innovation made the D-Type rock solid on the high-speed straights. Its impact is down to the relationship between the car's centre of gravity and centre of pressure, the point where lift acts. With no wing, the two are roughly centred, creating instability. By increasing the car's surface area with a fin, the centre of pressure moves further back, controlling lift and creating stability. Science that can also be seen through a speeding arrow.
This area here where we've got the feathers is just like the tail fin on the D-Type. As the D-Type's going down the Mulsanne Straight at 170 miles an hour, it doesn't want to be doing this. Same as the Archer's arrow, the tail fins just help it fly in a nice straight line.
So will world-class archer Kathleen McCarthy's shot from 25 metres prove fruitful?
When you're ready, Kathleen. Oh, nailed it! That's a wicked shot.
But when the crucial surface area of the feathers is removed...
Wow!
It's a different story.
Without the feathers or the fletchings on the back, the arrow has completely gone off course. Just proves how vital those feathers are and the fin on the back of the D-Type.
In the 50s, the Jaguar's game-changing fin helped to increase the D-Type's top speed from 172 to 192 miles an hour on the straight, powering it to an historic hat-trick of Le Mans wins.
This kind of success back in its day and age was unheard of. It's absolutely dominated Le Mans. The fin is a great achievement.
Aussie Invader's team are building on the D-Type's ingenious concept. After months of prototype testing,
So that man there is responsible for that. Look at that. Woohoo!
the final result is a state-of-the-art tail fin that they hope will one day keep Aussie Invader stable at 5 times the speed of the historic Jaguar.
So here she is. Here's our vertical stabiliser mounted on top. Without this component on their car, this car could not run straight. As soon as a bit like the rocket, the back end would want to pass the front and turn around themselves.
As with the Jaguar, the tail fin's surface area keeps the crucial centre of pressure to the supercar's rear. At around 400 miles an hour, aerodynamic loads will want to spin Aussie Invader round, but the tail fin's intricate profile creates an opposing force to this immense sideways pressure. Whilst the new innovation on the top of the tail fin will counteract lift.
The horizontal stabiliser works basically opposite to an aeroplane wing. When it's going through the air, it's creating a downforce of pushing it back down. And the beauty of this one is that if we have too much downforce on the back of the car, we can actually change the pitch on that horizontal stabiliser to the desired loading on the back axle.
But at super high speeds, Aussie Invader's front end will also face a major aerodynamic challenge. With 2.5 tons of propellant burnt in just over 20 seconds, the front's balance will continually change, making it potentially unstable.
So to compensate for that, with the front getting lighter, what we've got is the canards on the front that are computer controlled.
The canards are small pitchable wings, positioned behind the wheels.
As the weight comes off the front wheels, we get more wing put into it, the wing cranks down and pulls the nose down a bit harder. The canards at the front help us with that. It's a fine balancing act to get the car to run perfectly straight, and all I can say about that is this is the slickest land speed car that's ever been built.
Cutting-edge aerodynamics and a 200,000 horsepower rocket may, in the future, bring the land speed record into Aussie Invader's reach. But then the team will face their final impossible problem.
With the development of the car, the slowing of the car has to be a critical area of it.
With phenomenal forces at play, if this massive car isn't slowed down precisely, the run could end in disaster.
Everything's got to happen in the right sequence, going down from 1,000 mile an hour back to zero. It's a major job.
Aussie Invader is being built to rewrite history. The 763 miles an hour world land speed record is in its sights. And not only that, this team of engineers, headed up by creator and driver Rosco McGlashan, believe it will one day raise the bar to an unimaginable level as they target 1,000 miles an hour.
Rosco is probably a pioneer in the idea that a car can go 1,000 miles an hour. He's dedicated to the point where he's willing to put his life on the line for it.
If I can be the fastest man on earth, and it might only be for a day, I think I'd be a happy camper, and I might be prepared to hang the helmet up and go fishing. Come on, mate. Come on.
Over a decade of development has gone into Aussie Invader. When construction is complete, Rosco will be more than ready for his attempt at the impossible.
Lucky I'm slim. I should take that steering wheel off. It makes it a bit tight, put that on. Yep. Once I've climbed in the seating position here, the canopy's down, I'm secure, I've got my air breathing mask on, I've got my comms, I'm ready to go. Both throttle pedals go down and instant ignition, and I'm away.
62,000 pounds of thrust could launch this supercar to the magical 1,000 miles an hour mark in just over 20 seconds. But then the engineers will face their final problem.
With the development of the car, the slowing of the car has to be a critical area of it. From 1,000 miles an hour, to keep it in a straight line once the engine power goes off will be a challenge.
The distance is critical. He needs to allow himself plenty of distance or time to stop.
If they break this 9.5-ton machine too suddenly, Rosco will experience up to minus 16 G and could simply black out.
The difference between stopping a fast, light car as opposed to a fast, heavy car is a world of difference.
Conventional brakes are out of the question.
Everything's got to happen in the right sequence, going down from 1,000 mile an hour back to zero. It's a major job.
Surprisingly, it's an aeronautical innovation from the past that could provide a solution.
One last check of the controls. And we had full throttle.
In Idaho, former US Navy flight surgeon Dr. Rich Sugden is taking control of the FJ-4B Fury.
Here's coming up.
A 1950s trailblazer that holds a key to solving Aussie Invader's problem. Astonishingly, this 60-year-old jet can virtually reach Mach 1. But for the engineers who built it, slowing it from these speeds was perhaps their biggest challenge.
Jet aircraft need to be slowed down for two reasons. First, to land, and then secondly, they have to be slowed down in certain phases of maneuvering. The FJ-4B was designed to be a nuclear bomber, and part of that design required that it make a very steep dive from fairly high altitude.
Okay, we'll be taking it all the way to the end.
This high-speed maneuver hurtled the jet towards the ground at around 460 miles an hour. Controlling this dive posed a major problem.
You need some way to slow down quickly in an airplane that's going fast and is very slick, has very little drag. And you have to have something that can withstand high stresses.
This seemingly impossible problem taxed the greatest aeronautical minds. But Edgar Schmud and his team of design engineers at North American Aviation equipped the FJ-4B with a brilliant solution. They are known as air or speed brakes.
So these are the outboard speed brakes that come out when the gear is down. And in addition, there are ventral speed brakes that come out on both sides that stick down. They put the speed brakes on the fuselage versus being on the wings because they wanted pure drag. They didn't want anything that was going to affect the airfoil of the wing.
When diving on a target, all 4 air brakes were engaged, greatly increasing drag resistance. This allowed the plane to slow from around 500 to 200 miles an hour in a matter of seconds.
So the speed brakes are electrically controlled, which means it's just a switch that opens a valve, and then 3,000 pounds of hydraulic pressure is used to force these speed brakes out against the air. And doing 600 miles an hour through the air, there's a lot of force against these things, so there'd be no way to do this whole thing mechanically.
These robust engineering marvels help transform high-speed jet performance and still play a crucial role in the world of aviation. Aussie Invader's team have been inspired by this solution from the skies to develop their own trailblazing technology that they believe will one day bring the fastest car in the world safely to a halt.
So at 1,000 mile an hour, I pull both throttles back and the car will go from 1,000 mile an hour back to around 850 mile an hour.
At this critical point, Rosco will gradually engage his unique air brake system. The first phase of slowing Aussie Invader down.
Then I start inching the air brake, so I hit the button. 1, 2, 3, 4, 5, 6, 7, 8, and then fully open. It's a little bit like putting your hand out the side window on a car and feeling your hand get blown back. It's the same sort of drag, except 10,000 times that.
Electrical engineer Barry Fitzsimmons was involved in constructing these engineering marvels.
The air brakes are extremely important. They allow us to get away with about a 27-kilometre long track. Without them, yes, it would slow down, but it would take an awful lot longer.
A series of small holes stop air easily sliding over the air brake by firing the airflow in different directions, increasing braking efficiency by 30%.
The air doors themselves are extremely robust because they're going to be deployed into an airstream at very high speed. If one of these air brakes opened without the other, it would slew the front around dramatically. So they have to both open in sequence, and that's achieved by having a single hydraulic ram connected to the 2 hinges. They either both work or they both don't work, which is great. So that took about a year to design. Getting these made was a beautiful piece of engineering.
Keith and Jenny Lovett are responsible for Aussie Invader's second phase of braking, the parachutes.
So we would initially expect to drop the main high-speed chute out at around 800 mile an hour. It'll probably work all the way down to 600 mile an hour. You'll see that the top is vented, where it's allowing the air to go through. This is very similar to what you see in a space shuttle landing or a space capsule coming down.
The chute not only acts as a brake, its length also helps maintain a straight course.
If the car started at high speed to get sideways, pull the chute out, and this will suddenly give it greater stability because it effectively makes the car from its 40-odd feet now to over 120 feet because the parachute will be well back there. It's like a sea anchor. It'll help pull things into line.
3, 2, 1, fire.
Drogue guns have been developed to launch the chutes. Deployment takes just a quarter of a second. Following the high-speed chute, a second low-speed parachute is triggered at around 400 miles an hour, further decelerating Aussie Invader. With the end of its 24-kilometre run in sight, the final system, a set of rear-mounted disc brakes, can then be engaged.
If you can get the car down to 250 mile an hour before it uses the wheel brakes, that would be best, simply because it's wear and tear on the car. We expect to run it a number of times to get up to a speed record.
Through ambitious design and innovative engineering, Aussie Invader may one day change land speed history.
The whole car makes me very, very proud because it is like a 10 years accumulation of seeing it all come together. You stand back and think, God, did we really do that?
Overcoming extreme challenges to take on the seemingly impossible.
It's been my lifetime putting it all together, and I can't wait to sit my bum in that car and light the wick.
By building on the work of the pioneers of the past, adapting and breaking the mould themselves.
This car's come of age. I believe it's going to set the world on fire. It's going to be the first car in the world history to go 1,000 mile an hour.
The engineers are succeeding in making the impossible possible.